Hi everyone, I will explain about the Java architecture concept. What is Java architecture? What are the steps are required to compile and run Java application? Let me explain each and every step in the Java architecture. Look at this diagram. Enter the Java application is divided into two categories. The first category is nothing but a compile time environment. The second category is nothing but a runtime environment. In compile time environment, there are two steps are there, step 1 and step 2. In runtime environment, there are three steps are there, step 3 and step 4 and step 5. Then what is step 1 in compile time environment? The step 1 is represented as a Java source file. Whenever you write the Java source code which has been saved as a file name.java, then that is represented as a source code which is also be represented as a step 1. When it comes to the step 2, the Java compiler will compile the Java source code. If you write Java C space filename.java, the compiler will compile the Java source code. The Java source code is as per the standards of the Java, there is no syntax errors. Then it will be compiled successfully. The Java compiler will generate the dot class file, which is also be called as bytecode. There are two steps are there in compile time environment. These are the two steps are there in compile time environment. The first step, already explained, writing a Java source code. When the program writes the Java program in a .java file, then for example, the file can be saved as a hello world.java. This is called as a Java source code. When it comes to the compilation, the Java compiler compile the .java file. It checks for syntax error and translates the source code into the Java bytecode. If no errors are found in the Java source code, the compiler will generate the bytecode. Bytecode is a platform independent. It means that any irrespective of any operating system, the bytecode will be run. That is called as the bytecode is a platform independent. These are the steps are in the compile time environment. I move on to the runtime environment. There are three steps are there in the runtime environment. Step 3, step 4, step 5. In runtime environment, there are three steps are there. First step is a class loader. What is class loader? A class loader load the compiled .class files into a memory. Whichever .class files have been generated by the compiler, all those .class files will be loaded into a memory by class loader. In addition to that, it also loads required Java class libraries. All these classes are available for execution. Then step 4 is represented as a bytecode verifier. What is the use of the bytecode verifier? Look at this here. The bytecode verifier checks the loaded bytecode for what? Security violations, illegal code to be accessed, the memory access issue. Security violation means any private data is accessible from outside the class, because any third person has to be changed the bytecode. If you change the bytecode, the private data is not able to access from outside the class. That will also be checked by the bytecode verifier. Any illegal code is there in bytecode, that is also be checked by the bytecode verifier. Memory access issues, stock overflow and stock underflow, this kind of issues will also be checked by the bytecode verifier. Whether the bytecode is secured or not, it will check by the bytecode verifier. Everything is fine, then only the bytecode will get executed. Otherwise, the bytecode doesn't execute. Stepwise what? Java interpreter or just-in-time compiler. Whenever bytecode is verified your code, when the bytecode is safe, then the bytecode will be run by Java interpreter or just-in-time compiler. Then what are the difference between the Java interpreter and just-in-time compiler? We'll see in the slide. Look at here. The step 5 is represented as a Java virtual machine execution. The JVM execute the verified bytecode. Inside the JVM, there is a Java interpreter and just-in-time compiler. The Java interpreter executes the bytecode line by line. Execution is very slower to compare with the just-in-time compiler. When it comes to the just-in-time compiler, convert the bytecode into a native machine code for faster execution. Generally, the Java interpreter will be used for smaller applications. The just-in-time compiler has to be used for larger applications because the execution is faster than Java interpreter. Okay, this is the difference between Java interpreter and just-in-time compiler. Then, whenever the Java code when Java bytecode is executed, it interact with operating system and hardware are required to run the Java applications. These are the steps are required to compile and run Java applications. The summary of the step 1, write the Java source code. Step 2, compile the Java source code. It will be convert the Java source code to a dot class file. The dot class file is represented as a bytecode. When you come to the step 3, the class loader loads classes and libraries which are required for running the Java applications. When step 4, the bytecode verifier checks code safety, whether the bytecode is safe for execution. When it comes to the step 5, the JVM will execute the bytecode either by using interpreter or just-in-time compiler. It will communicate with the operating system and hardware. With help of OS and hardware, the Java program will run. These are the steps are required to compile and run the Java applications. If you have any doubt regarding these steps, you may ask at any time through the comment box. Thank you. Thank you all for watching my videos.